All right, guys, let's look at section 4.4. Now, this is kind of a, I don't know, different than what we've been doing. It pertains to the same type of things, but we're not learning any new rules, really. We just have a couple theorems that we're going to talk about. So we're going to be doing this foldable that looks like this. So by itself, it looks like this, and then there's stuff on the back as well. So what we're going to do, how to fold this, is I need you to fold along this line here like a book. Okay, so fold along this line, and what you see here on the right should be like the cover to a book. So go ahead and do that. Okay, so after you've folded it like a book, open it back up, and then there's this line here. You're gonna cut this line, but don't cut all the way through it. Cut it to where this top and this bottom become flaps, and then you could open the flap to see the content. All right, so the top one is the reflection in parallel lines theorem. And so the flap looks like this on the left, and then the inside, there's two examples, and the two examples are like left and right when you open it up, but I put it top and bottom just to better fit on this paper. So let's do the flap first. Reflections in parallel lines theorem. If lines K, which make sure you look at this diagram or it's not going to make sense, so here's line K and here's line M, if they are parallel, okay, then a reflection over line K, so we're going to reflect over line K, and then we're going to reflect again over line M, that is going to be the same as a translation equal to twice the distance, or 2 times, maybe I should put 2 times the distance between lines K and M. So in other words, if we take this segment AB, we reflect it over line K, and then we reflect it again over line M, line A double prime, B double prime, AB, so I could say here, AB would be a translation, A double prime, B double prime, that is 2D apart. Oops, apart. Okay, so now notice from here to here is D. So that means from here to here is double that. All right, so let's look at the first example. So if you open that flap up, this one would be on the left. It says the distance between line K and M is 1.6 centimeters. Okay, what is the distance from P, this figure is P, to P double prime? Okay, so from here, what we're going to do is we're going to reflect it over K, and then we're going to reflect it again over M, and these two lines tell us that these are parallel lines. Okay, so we go back to this theorem. We know that if we do that, then from P to P double prime is just a translation. Okay, it's just the same as shifting it over. Now, if this is 1.6, this here is double that, so 2 times 1.6. 2 times 1.6 is 3.2, so I'm just going to say a translation of 3.2 centimeters, and that would be my answer. All right, now let's look at the right hand. On your foldable, it'd be the right hand example. It says here the distance between P and P double prime, so here's P, and here's P double prime. We know the distance from here to here is 5 inches. What is the distance between line K and M? So once again, we're reflecting it over line K to get P prime, and then we're reflecting it again over line M to get P double prime. And we know that these two lines here are parallel because of those two arrows. Okay, so 2 reflections would result in a translation, and that translation would be double the distance between the lines, okay? Well, we know the distance from the translation is 5. We want to know the distance between the two lines. So that would just be 5. If we cut that in half, it'd be the same thing as divided by 2. And 5 divided by 2 is 2.5 inches. All right, let's go back to the front of it, and you should see this, the reflections and intersecting lines theorem. So if I fill this out, it says, if line K, which is here, and M, which is here, if these lines are intersecting, so if they intersect each other, and here they intersect at point P, then a reflection over line K, and then another reflection over line M is the same as a rotation about point P, which is the line that those two lines intersect at. Now I know the angle of rotation, so from here to here is double the measure of the angle formed by the two intersecting lines. So if the two intersecting lines is K, the angle of rotation is 2 times that. All right, let's look at this first example. Now this first example, if you open your flap on your foldable, this first example is on the left, okay? So in the diagram, the figure is reflected, so we start with here, and we know that because this is our F. We go from F to F prime to F double prime here, okay? So we start with this L-looking figure here, okay? And it tells us we reflect it over line K, and then we reflect it again over line M. So we want to describe a single transformation that maps F to F double prime. So when we reflect it over these two lines, it gives us that these two lines intersect at an 80-degree angle. Okay, well this theorem right here tells us that if we reflect it over two lines that intersect, it's the same thing as a rotation. Okay, and that rotation, so if I were to draw from here to here, that rotation is going to be double the measure of the angle formed by the intersecting line. So rotation of 2 times 80 degrees, or rotation of 160 degrees. All right, let's look at this last example here. Now this is on the right-hand side on your foldable. So it says a rotation of 76 degrees maps C to C prime. So if my C is here, my C prime is right here, and let's just say this is a rotation of 76 degrees, okay? So I just drew a picture of that. Okay, now it says to map C to C prime using 2 reflections. What is the measure of the angle formed by the intersecting lines? So it's saying if I want to reflect it over 2 lines, here to here, and then here to here, what would be the measure between those 2 lines? So let's say we have a line here and a line here. Say this is L, this is M. Okay, so we're going to reflect C over line L to be here, and then we're going to reflect this over line M to get here. We want to know what is this angle measure right here. Well, kind of like we did up here, the angle between the 2 lines is half the measure of this whole thing, or the measure of this whole thing is double the measure between the lines. Well, we know the measure of the whole thing is 76, so we want half that, which is 38 degrees. So it would be a rotation of 38 degrees.